Our previous car example allowed us to sort of get to know MATLAB's graphic user interface and how we can ask MATLAB to create functions and scripts for us, right? So, um, so in the previous car example, we're mainly using the button clicks, right? So button clicks, we can get a lot of things accomplished, from importing data into MATLAB to quite sophisticated processing of those data and making plots and making really sophisticated graphics that actually allows us to visualize the dataset. All of those things can be accomplished by using just the graphic user interface and by just through button clicks. But MATLAB is actually a lot more capable than just a graphic user interface. It allows you. It's a full-featured programming language. It allows you to actually write very sophisticated computer programs that can be executed not just on CPUs but also on GPUs, not just on one computer but on multiple computers in parallel, that kind of thing. So to understand MATLAB as a kind of a full-featured programming language, we need to write our own codes. Right? Instead of asking MATLAB to create those codes for us, and sometimes we do want to do that because we want to avoid writing codes as much as possible, because writing codes is always a kind of error-prone process. But in order to really understand MATLAB as a programming language, we need to write our own codes. So in this video, we're going to work on a relatively simple example. And this example is taken from our textbook, An Engineer's Guide to MATLAB, which is the 3rd edition. That's example 1.2 in that book. It's quite a straightforward problem. It just involves typing up this really sophisticated equation inside of MATLAB. Right? And the purpose for this particular exercise is to allow us to sort of get a glimpse about those built-in functions provided by MATLAB. Right, so you can sort of see sine here, the square root, cosine, the power, that kind of thing. Some of the built-in functions, right? Some of the built-in functions. MATLAB actually has a quite wide collection of built-in functions. So, for example, it allows you to compute lots of special functions, right? And sine, cosine, those trigonometry functions are kind of one kind of example of it. When we write computer programs, any kind of computer programs, not just MATLAB programs, we need to be quite careful about how we type, right? How we actually write the codes, basically. So for this kind of sophisticated equation, really complicated, we need to pay attention to precedence, right? So those subtraction is going to happen inside the parentheses, right? Those sign, those functions has to be applied to 2 theta, right? The precedence, which operation needs to be computed first and which operation needs to be computed earlier than other operations, and how we can actually decompose a really sophisticated formula into like multiple components, and then eventually how do we put those components together, right? And a second thing that we want to understand is sort of the kind of a difference between MATLAB scripts and MATLAB functions, basically. So when we did the car example, we asked MATLAB to actually create both the functions and also scripts for us, right? And we used the live script, kind of a rich text format script, right, as an example, right? But in this example, we're going to use the ordinary script, right? We're going to write an ordinary script to implement this particular equation, and then we're going to also implement the same equation by using a function, and we're going to sort of take a look at the kind of differences between scripts and functions, right? And a third thing that we want to sort of look into is when we write a computer program, this computer program looks more or less like a black box to the user, to the end user, right? We need to gather some inputs from the end user and then display the output, right? So how do we actually gather inputs from the user, right? And MATLAB actually provides a quite simple function for us to do that. It's called input. Right? It's a very simple function for this kind of text input. Just by using the input function from Matlab, we can gather inputs from the user. Right? Now let's look at the equation. What this equation actually is about. Right? It's for describing the flow in a circular channel. Right? A flow in the circular channel. The graphical representation of the whole thing is this kind of thing. So you have a circular channel, and then you have fluid. Right? And then the height from the bottom of the channel to the sort of free surface of the fluid is d sub c. And the diameter of the circular channel is d, small d, right? So the radius is half d. And then you got an angle. So this is actually the center of the circular channel. This cross is located at the center of the channel, right? And then this particular angle, it's from this part of the from this radius to this radius, it's 2 theta, right? And the flow rate Q, as which has a unit of cubic meter per second in this particular channel, in this particular setup, right, can be computed by using this particular equation, right? So it's 2 to the 2/3 power. One and a half, right? 1.5 power, and then d sub c is the height, right? And to the 2.5 power, and then square root of g is sort of the gravitational constant, 9.8, and then theta subtract 0.5 sine 2 theta. The whole thing has to be raised to like a 1.5 power, right? And then that's the numerator. Right? The denominator is 8 times square root of sine theta, and then 1 subtract cosine theta, and then the whole thing to the power of 5 divided by 2, right? And then d sub c has a formula for computing d sub c. D sub c can be computed just in a geometrical way, right? So 1/2 d subtract 1/2 d times cosine theta. So that's the equation that we need to type up in Matlab, and then the input is basically just going to be the diameter of the channel d, right? And then the angle theta, right? Because g is a constant, 9.8. That's not an input, but this d, the diameter, and the cosine theta, the theta angle must be entered as the input. So let's try to work on this particular example, right? We're gonna write a script first, and then we're gonna write a function for it. Because I still need the window, because I need to look at the formula. So I'm gonna put this thing aside, and then open Matlab in a different window. All I need to see is basically the equation, and then I have Matlab. But I need to sort of put Matlab in a kind of smaller window. Do full screen. Drag it down. Yeah. So it looks like it's gonna be this kind of smaller window. Okay, so how do we actually open the editor window, right? Editor pane, or you can just type the command edit, and then followed by the file name. The file, for now we don't really have any files on our current working directory, which is user, pchen, and desktop, right? Let's create a new file. It's called a flow in circular channel.m. So it's basically just saying that this particular file doesn't exist in the current working directory. Do I want to create it? Yes, I want to create it. So now I'm inside of my editor box, right? So maybe it's a good idea to just minimize this part. then also minimize this part. I'm still gonna need them later on, but for now I don't really need to do anything. Right. So what's gonna be the input? Right. What's gonna be the input? Let's give D a value, some kind of a. The first thing that let's write a comment flow in a circular channel. Let's just tell the user of this particular script what we are gonna what's the purpose of this particular script, right? So sometimes it's a good habit to actually, before we actually run anything that's kind of useful, let's clear the workspace. Semicolon to suppress the output. So this particular command, clear all, is going to clear out every variable that's inside of our workspace, right? So before executing anything, before creating new variables, I want to delete all the existing variables in my workspace, right? So we have a clean slate to start with, right? And then if there are multiple graphic windows, for example, right? If there are multiple graphic windows, that's kind of open, right? And we need to create a new graphics, that kind of thing. There's another command that's called close all, right? That's gonna allow us to close all existing windows, basically, right? So using clear all usually decreases code performance and is often unnecessary. So it's giving me a warning, right? So do I still want to do it, right? Suppose if I do not want to do these things, I can just add a comment in front of them, right? And then those two lines will not have any effect. But let's still sort of do that, right? Now let's try to type up our equations. So the two inputs, which is D and theta, right? D and theta. So D, let's give it a 1.0, right? Some arbitrary number, and then theta. So if you want to sort of use this kind of Greek letter, it's not going to work, right? So in a rich text sort of environment, you may have the ability to actually insert theta as a Greek letter inside of equations or inside of a text, right? But if you are sort of writing the computer program in Matlab, right, a computer program that will be executed by Matlab, right? Those lines will be executed later on by Matlab, right? If you try to type a Greek letter or insert a Greek letter of theta, like that kind of thing, right? First of all, it's kind of difficult to actually find it on the keyboard. You won't be able to find it on the keyboard, right? If you are trying to use this kind of a Unicode thing, it's not going to work, right? So what we usually do is just to convert the Greek letter to their English name, right? So theta, just type theta, type the spelling of the theta, and then give it some kind of value. Depending upon what's going to be the unit you're going to. So for angle, theta is an angle, right? So what's the unit? You can have different kinds of units for the angle, right? Degrees or radian. Degrees or radian. In practice, usually, not just in Matlab, but also in many other kind of programming languages, when those built-in functions, like a trigonometry function, sine and cosine, they usually take radian angles as input. So, but the user of your program usually enters degrees, for example, because for people, the degrees seems to be more natural, right? So let's just assume theta is in terms of degrees, 60.0, right? So that's degrees. Right? And when we actually give theta to those trigonometry functions, we need to actually manually convert theta into a radian, because those functions, sine, cosine, those built-in functions, Matlab's built-in functions, take radian as input, right? So the first thing we might want to do is just to convert theta into radian, maybe, right? How do we actually convert theta into radian? Theta times pi divided by 180.0. So convert theta to radian. Right. So what does this line actually mean, right? So first of all, pi, this pi symbol, right? This pi symbol, So pi is actually one of those MATLAB's built-in constants, right? So if in the command window you type pi, it's gonna display the pi 3.1416, right? And if you want to see more digits, you can sort of do a format long and then type pi. Then it's gonna display a lot more digits, right? So MATLAB actually has several built-in constants, right? So pi is one of those constants, right? Pi is one of those constants, and you can get this constant by just typing the two letters p and I, pi, right? Not the Greek letter, but the English word pi. Right? If you type pi, and then MATLAB is going to display its internal value that's represented by MATLAB. So basically, what you're actually doing is you are using the current value of theta. The current on on the right hand side. On the right hand side, you see an expression, right? That's theta times pi divided by 180 degrees. So that's the stuff on the right hand side of the assignment operator. And then you have a left hand side for the same assignment operator. That's also theta, right? So in mathematics, this is like a crazy, right? Theta is never gonna be equal to theta times pi divided by 180 degrees unless theta is like a 0 or something, right? But that's in mathematics. In computer programs, it's not the same thing. This equal does not really mean comparison. You are not comparing the left hand side with right hand side. You actually this one equal sign is actually means assignment. You are actually assigning the value of the expression on the right hand side to the left hand side. So theta is basically treated as a container. On the right hand side, you are computing some kind of value. Right, and then once the value is computed, you are putting that value into this theta container. Right, so when we did the car example, we looked at the double equal. Right, that's a comparison. So in mathematics, this is the double equal in computer program is more like the single equal in mathematics. In mathematics, single equal means comparison, but in computer programming, it's double equal means comparison. So single equal actually just means assignment. So what this line actually means is that, so I need to compute the expression on the right hand side. So how do I actually compute it? I need to use pi, but that's provided by MATLAB. So whenever MATLAB actually sees pi, it's going to replace it with 3.14, this kind of very long number, right? And then I also need to use the value that's stored in theta, right? So what's actually the current value stored in theta? It's actually 60 degrees, right? So the current value that's stored inside of theta is actually 60 degrees. So it's going to take 60 degrees, multiply with pi, and then divide by 180, right? So why do I actually do this constant, right? Because 180 degrees is exactly pi in terms of radian, right? So 180 degrees is equivalent to pi radian. So theta is currently in degrees, right? So theta degree divided by 180 degree, that's sort of a proportion, right? It's a proportion between theta and 180 degrees. It's a fraction, right? And the same fraction times pi, you get the radian you get the radian, right? So once this expression is evaluated, we're gonna get a number, and we can assign that number back to theta, right? So after this line is completed, the theta is going to have a value. So the theta container is going to contain a value that corresponds to the radian of 60 degrees, right? So that's going to be that's converting theta to from degrees to radian, right? And then later on we can just use theta inside of those trigonometry functions, right? And then the next thing we want to do is to do what, right? So here we can sort of see lots of very complicated things, right? And then d sub c is one of those variables. Right? And if I just try to type up the q, right, the value for q, the expression for q, then it's going to be quite long. And then it's going to require a value from d sub c, right? So when we write mathematical equations, we can write this expression first and then write d sub c next, right? But when we write computer programs, we have to sort of pay attention to the order, because when we compute the q, we need to use d sub c as its as one of those inputs to this particular expression, right? In this particular expression, we need to use d sub c, right? We need to use d sub c. So when we actually type up the expressions for q, we need to have a value for d sub c already. So the ordering becomes really important, right? We need to type up the expression for d sub c first, and then we can actually use the value that's computed for d sub c inside of the expression for q, right? So if you just type up the expression for q for d sub c raised to 5 divided by 2, that kind of power, it's not going to work because d sub c hasn't been evaluated yet. It doesn't have a value, it doesn't have a variable that's called d sub c yet. So before we type up the expression for q, we have to actually define d sub c first, right? So let's write d sub c, the expression for d sub c. D sub c, let's again, here it appears as a subscript. C appears as a subscript, all right? But when we actually write computer programs, you cannot really use superscripts or subscripts. At least for Matlab, you cannot do that. For mathematical, you can maybe you can do that, right? But Matlab, you cannot do that. There's no subscripts, superscripts. So if you want to use d sub c, you can just type dc, right, with a capital D, small c, right? So there's no superscript or subscripts, and then that's going to equal to d divided by 2, and then multiply. So this is division. So this is division, Matlab division. This is multiplication, right? A star means a multiplication. In Mathematica, you probably don't really need a star, right? You can just sort of use a space or a dot or something, right? But in Matlab, you have to use a star to indicate multiplication. And then you have parentheses. It's 1 subtract cosine theta. Right. So theta, the cosine function is a built-in function. It's a Matlab built-in function. You can just use it as a mathematical function, just with cos, and then give it the input. The input is the angle in radian, theta. Right. And then you can just 1 subtract cosine theta. It's just 1 subtract cosine theta. And then there's a parenthesis around it, right? Parenthesis, that's the parenthesis. Right. So one of the things that you have noted, you must pay attention to, is that cosine theta is a function. So every input to this particular function must be inside of the parenthesis. Parenthesis here, right? So this parenthesis is mandatory. You cannot just write cosine theta like that, right? You cannot do that. It's not going to recognize. If you put a space here, it's still not going to work, because cosine is actually a Matlab function. You are basically calling that particular function here, right? The correct way for calling the function is to give the input inside of a pair of parentheses. So you must put a parenthesis here in order to actually call the cosine function inside of Matlab, right? This is given, theta is given to the cosine function as an input, so it must go inside of the parenthesis, a pair of parentheses, right? And the parenthesis that comes here is for grouping, right? You need parentheses in order to actually do this multiplication. The multiplication with half d is with 1 subtract cosine theta, the whole thing. It's not with 1, right? You need these parentheses to actually do the subtraction first before doing the multiplication with half d, right? I think that's all I want to say about this particular expression, right? Once we have d sub c, we can try to type up this particular formula now. But this particular formula is quite complicated, right? It's quite complicated. So to avoid mistakes when typing up these kind of really complicated expressions, we can try to decompose it. We can try to decompose it into like multiple components. So this is a division. So it's got a numerator and it's got a denominator. The denominator is slightly similar, right? So let's try to write the expression for the denominator first. Let's just call it a denom. No, let's call it a q denom. Yeah, maybe that's a it's not a good name, but anyway, it doesn't matter too much. So it's 8 times the square root of sine theta. So it's 8 multiply, right? Multiply, you cannot forget to type up the star. If you forget to type up the star, it's not going to do a multiplication. So it's 8. The mathematical formula doesn't have a multiplication here, right? But the multiplication is implied. So if you have no symbol here, then you imply a multiplication. But Matlab, or in writing any kind of computer program, this multiplication has to be explicit. If you just put nothing in there, it's not going to be, there's no multiplication implied. And then the square root of sine theta, right? Sine theta, we saw how to use cosine theta, right? So sine theta is pretty much the same thing. That's sine theta. And then the sine theta has to go inside of the square root function. So square root has a function name called sqrt, right? Sqrt means square root, and it's also a built-in MATLAB mathematical function. It's just like sine and cosine, those kind of functions. And sqrt is a MATLAB function for taking the square root, right? So it looks like a simple expression, right? But in fact, it actually involves 2 function calls here. The first function call is the sine theta, the sine function with the input of theta, right? It's a sine theta. So theta is given as the input to the sine function. And then the result of calling the sine theta, so basically the value that's returned by calling the sine function, is used as the input to the sqrt function, right? So this whole thing, the output of the sine theta function, sine theta call, is going to go into the square root call, sqrt function call, as a input. So it's inside of another pair of parentheses, right? Another pair of parentheses, right? And again, for every level of function call, you must have parentheses around the input, even though the input now is actually the output of the sine theta call, right? Calling the sine theta function, right? And then the result of the square root call, the call to the square root function, is multiplied with 8 here, right? And then let's keep writing. Multiply 1 subtract cosine theta, and then the whole thing takes 2.5 power, right? So we have to use a parenthesis to group 1 subtract cosine theta, right? It's 1 subtract cosine theta, and then we need to raise the whole thing by a power that's 2.5, right? So how do we actually get the power? In Matlab, you use the hat, the pointed hat. You have to hold down the shift key and then press the number 6 on your keyboard to get the hat, get a pointed hat. And then the power is 5 divided by 2, right? 5 divided by 2, that's 5 divided by 2. And then 5 divided by 2 is again inside of parentheses because this division actually has lower precedence than taking the power. So if you forget about if you do not use the parentheses, then the whole thing, 1 subtract cosine theta, is going to be raised by a power of 5, and then the result of the power is going to be divided by 2, right? It's not going to be the expression that you want, right? That's the denominator. And now let's write the numerator, right? Q let's just call it QNUM, right? And then the expression is even more complicated. It's 2 to the 2/3 power. So 2 to the 3 divided by 2, this power. Multiply. Now it's d sub c to the 5th divided by 2 power. See? And now it has to use d sub c. The good thing is that d sub c has been created. right? If we actually write this expression as a mathematical expressions and type up q first and then try to type up d sub c, it's not going to work, because when we type up the numerator for the q, it needs to use d sub c, and if you define d sub c later on, later than q, then when we type the q, it needs to use the value inside of d sub c, but d sub c hasn't been created yet, right? There will be a logical error. So Matlab only knows to execute the code from top to bottom. It doesn't really know to look into the later part of the code to find the d sub c. It doesn't really know that, right? So you have to sort of create the d sub c before you create q, right? So now it's d sub c, and then the power is 5 divided by 2, right? And then times the square root of g, But did we actually define a g here? Right? We haven't actually defined a g. But let's see what Matlab is going to tell us. Theta subtract 0.5 times sine 2 times theta. This multiplication sign is extremely easy to forget, right? Because it's 2 theta here, and it's in the innermost parenthesis, right? But you cannot forget about this multiplication. It's 2 multiply sign. If you just type 2 theta, it's not going to work, right? And then let's close this bracket, and then raise it to the power 3 divided by 2. Right, that's denominator. So Matlab is not telling us that we're missing a g here. Right? So it requires us to use g, but g is not defined yet. So if we type g, this undefined variable, right? So if we try to execute this piece of code, right, it's going to tell us g is undefined variable. Right, undefined functional variable g. Right. So if we actually put the g later on, so say g equals to 9.8, we execute it again. It's actually giving us exactly the same error, undefined functional variable g, right? The only way for this thing to work is actually move g to in front of this particular expression. G equals to 9.8, right? It doesn't really matter where g actually appears. The only thing that matters is that the g equals to 9.5, this definition has to be before sqrtg, before you actually use the value in g, right? As long as you define g before you use the value in g, Matlab is going to take it, right? And now we can compute q. Q equals to q num divided q denorm, right? And by now we have finished our calculation, right? Let's just run it. We should be able to get a q inside of our variable, right? And it's that's d sub c, q, right? That's q. Gives us a 0.1012, right? So that's how we actually write this particular function. Write this how we actually do this calculation by using a Matlab script, right? Sometimes you may want to display the result, right? If you want to display the result, you can just do a disp, right? Disp flow rate q equals 2. We can put the whole thing here, right? And then q num to str q. Right. So here we are using the Matlab's built-in function called disp. Disp is going to do a display. It's going to do a printout on the command window. So now if we run this same script, it's going to display this thing, flow rate q equals to 0.1012, right? And then suppose we want to give it a unit, m cube divided by second, right? We can do that here, right? That's going to give you a unit. meter cube per second. The input to the disp function is usually a string. It should be a string, right? So here it's a string, flow rate q equals 2, because it's inside of this pair of single quote, right? That's a string, right? And then that's another string. It's space. We have space here. Space meter cube divided by second. That's another string because it's also inside of the pair of single quote, right? But the value of q is not a string. The q is actually a float. It's a double, actually. It's a double. It's a floating point number. It's not a string. So in order to actually do a string concatenation, to connect all those strings together, we have to convert q into a string. And Matlab provides a function, again, an internal function, called num to str. Right? This num to str function allows you to convert a floating point number, q here, to a string. So you are calling num to str function and give q this double as its input. And this particular function is going to output a string. And here, how do you actually do the concatenation, right? Concatenation of the string, how do you actually do that? All you have to do is to actually put those different strings into a pair of square brackets. And then those different strings are separated by a comma. Right? And then it's going to give you a string. So when you do function calls, it's parentheses, right? You have to pay attention to the brackets here. So the inputs to the function is grouped by parentheses, right? And when you actually try to build some precedence into the calculation, you also use parentheses, right? You also use parentheses. Those parentheses allow you to actually have a precedence for the calculation inside of the parentheses, right? But when you actually try to concatenate strings together, you are using square brackets, right? Later on, we're going to see that these square brackets is actually very important. It allows you to actually construct matrices, construct vectors and matrices. So Matlab is called Matlab is because originally it was designed to actually do matrix calculations, right? So linear algebra calculation, matrix and vectors are like the fundamental building blocks, right? Those square brackets inside of Matlab allows you to construct matrices and vectors. So basically here you're actually putting 3 strings. You are using 3 strings trying to construct a matrix. It's a character matrix, right? So if Matlab actually sees that, it will try to actually concatenate those strings together, and then eventually gives you this particular printout, right? So that's the printout. That's the printout, right? And now let's try to actually use the. So for now the input diameter and the theta, these 2 inputs are kind of built in, right? Built into the script. If the user of the script wants to change those values, he or she has to actually come to the script and change the source code. This may not be something that's kind of desirable. You probably don't want to do that, right? So what you want to do is that when the user of the script executes this particular script, he or she can just click on the run button, and then the command window is going to ask the user for the required inputs. And Matlab actually provides a quite simple function for you to do that. So here it's a fixed number, right? Here it's a fixed number. So all I have to do is to replace that fixed number with the function called input. Right. And again, Matlab has this particular input is provided by Matlab. We didn't actually wrote the code, right? Matlab actually provided this particular function for us. It's called input, right? It's called input. And this input function takes a string as input. So you have a parenthesis here, right? And this parenthesis can take a string as input. And what's actually the meaning of the string, right? The meaning of the string is the prompt to the user of the script. It's gonna. So let's give it a try. So please enter the diameter. of the channel, and then give it a comma, colon, and then a space, right? So now when you execute this particular line of code, when Matlab actually executes this line of code, what's going to happen is that inside of the command window, so let's clear up the command window. The command for clearing up the command window is called COC. Right, once you type COC, the command window is going to give you a very clean command window. Now let's run it. Right. So as soon as I click on the run button, I see this particular line. Please enter the diameter of the channel. Right. But why Matlab print out this particular line? Because when I did this input, I gave the input function this particular string as the input function, as the input to the input function. And this input is going to be the prompt that's going to be displayed in the command window. It's telling the user of this particular script what's supposed to be entered, right? Suppose we give it like a 5-meter diameter, right? And then it's gonna let's just press return, and then it's gonna execute all the lines in the side of the script, and then show us the result, right? That's gonna be the flow rate. Right? And another input is theta, right? Another input is the theta. So what we can do is again replace this hard-coded number with the input. And then let's tell the user what's supposed to be entered, right? Please enter the angle theta in degrees, right? And now let's run it. Then we're gonna have two inputs, right? Enter the diameter of the channel, say 5, right? And then enter the angle theta in degrees, 60. And then that's gonna print out. It's gonna print out the flow rate Q, right? So that's how we can actually solve this problem using a script, right? But it's a kind of a very long formula, right? It's a very long formula, and it takes multiple steps to actually create the expression for it, right? So if we want to sort of reuse this particular code multiple times, it might be beneficiary to actually create a function to encapsulate all these lines. How many lines? That's 1, 2, 3, 4, 5, 6 lines of code, right? So if we can actually replace these 6 lines of code with just a one function call, then we can make our code, make this particular script sort of shorter, right? So how do we actually create a Matlab function, right? We can create a Matlab function to actually enclose these 6 lines of code. So now let's try to create the function, right? Again, we type edit in the command window, edit to what? Or another way, if you want to use the graphic user interface, you can just click on the new button. You have an arrow here, right? And then if you click on the arrow, the triangle, inverted triangle, you have a choice, right? Script, live script, function, right? You can click on function. Then it's gonna open up a template for the function, right? So function, that's the keyword, right? And then output arguments is telling you the output arguments inside of the square brackets, right? And then you can just replace the output arguments with Q, for example, right? And then untitled input arguments. So untitled is going to be the function name, right? If you don't change it, let's change it. Let's change it to a more meaningful name, right? Let's call it flow rate. Circ channel, right? And then input args. We have actually 2 input args, right? One is the diameter d, and the other one is the theta angle, right? And then now we can actually write the body of the function, the first thing we want to do is to actually write a comment to tell the user of the function what the purpose of the function. Compute the flow rate inside of a circular channel. If we want multiple lines of comment, we can just circular channel, compute the flow rate inside of a circular channel based on diameter and angle. See that, right? So now let's just copy over all the codes. Right. We can actually cut over all the codes. Right. Just select them, and then Control X should allow us to cut it. And then Control V should allow us to paste it. Right? And then all the logic for computing the flow rate is sort of goes into this particular function now. Right? And then let's save it. And then it's going to ask us to pick a function name. Oh, so it's got a correct default function name. Let's just save it. Right? And now if we go back to our script, we don't really have to sort of use that 6 lines of code anymore. We can just replace it with Q equals to flow rate circ chain, and then give D and theta as input. Right? And now if we execute this same piece of code, the same script, right? If we execute this same script, again, it's asking us to enter the diameter of the channel. Let's give it a 5, and then enter the angle theta in degrees 60, right? Then it's going to print out this particular flow rate. So that's how you can actually encapsulate the logic for this particular formula into a separate function by hand, right? Without asking Matlab to create it for you. In fact, Matlab cannot actually create this thing for you. You have to sort of type it up in Matlab. Right? And we have seen some of the built-in functions, square root, cosine, sine, these kind of trigonometry functions. It's got lots of fundamental functions built into it, right? You can actually Google it. And then how do we actually use that function inside the script, right? Just by calling it. And assign the output to a separate variable, right? And how we can actually get the inputs from the user by using the input function call. Right? Yeah, so that's this example flow in circular channel.